All right, here's our video on geometry, and we're going to talk about similar triangles. We have AA, SSS, SAS, and there's more. But AA is just angle, angle. SSS is side, side, side. And what do you think SAS is? All right, you got it. Side, angle, side. So we'll go over these, do some problems with it. Let's get our pen ready so we can do it. All right, let's not use red, let's use yellow. So let's start with AA, angle, angle. So the postulate, thanks to Euclid, by the way, Greek philosopher, lived about 300 BC or BCE, whatever you're using. A little over 100 years after Plato, just to give you a little reference. But he came up with all these postulates. Anyway, if two angles, and you just need two angles of one triangle. This is almost common sense, some of this stuff you'll see. If two angles of one triangle are congruent, fancy word. Here's the symbol for congruency. So basically it's just saying are they're equal, right? Same shape, same size. That's what congruent means. So if two angles of one triangle are congruent to two angles of another triangle, guess what? The triangles will be similar. And here's our symbol for similar. So in other words, they have the same, they're the same, they don't necessarily have to be the same size, but they just have to be the same shape on those triangles, and they have the same angles. So for example, here we'll have a triangle here. We'll call it triangle 1. And maybe this one over here is triangle 2. Now, we'll say triangle 2 is bigger. It's larger. Of course, by perspective, one could be larger, right? But we're not dealing with perspective here. So let's say we'll just label these A, B, C, and the angles are capitalized, and the sides are in lowercase, so that would be A, B, C. But that's not important. And we'll say for this triangle, let's just say D, E, F. So we want to know, let's say that angle A over here was 60 degrees. Put a little 60 in there. And let's say we have 60 degrees in angle 2, in the triangle 2. So we only have one angle, so we can't be sure that they're the same yet. But let's say we put a 52 over here, and then I put a 68 over here. Are these triangles similar? Well, we should know something about the triangle sum theorem. Let's make a little box, write this triangle thumb, not thumbs, sum. The triangle sum. I said thumb, right? Theorem or postulate, right? You can hear it. So it's, with this theorem, we know that triangles are 180 degrees. They have to sum to 180 degrees. So what will be missing? We'll put a little X there and a little Y there. What will be missing in these triangles to get 180 degrees? So we know we have 60 plus 52. We need another number to get to 180 over here. What'd you get? You get 68, right? So we know that we have 68, put a little line, that's 68 degrees. And already we know that there's a 60 here, there's a 68 there, there's a 60 there, there's a 68 there. So we already know that Y has to be 52. This has to be 52 to equal 180. So we know that these two triangles are similar. And they're similar because the postulate says if two angles of one triangle are congruent to two angles of another, they will be similar. They both have two angles. You can see, well, obviously they have all three, but you see that they both had a 60 and a 68. That's the two angles. That's all you need. So they're similar. Because by default, the third one will be the same also. So AA is pretty simple. All right, let's clear this out. Let's do one with side, side, side. Side, side, side. This one's pretty common sense also. I'll just draw some triangles here and see if they're similar. We'll just call this one, let's say JLK. Doesn't really matter what letters we use. Let's say there's another one over here. And they're not drawn to scale. We're just using this for reference. And we'll say this is MPQ. Why not? And let's say we had 12 over here. We had 16 over here. We had 8 over here. And let's say over here we had 6, 9, and 12. So how do we know that triangle JLK is similar? And this is a good question here. What would you put for letters here? So I said, and you could put any letters in the start. So I said from J to L. I'm going from J to L, which is the middle number, right? The largest number is 16. J to L is the middle number. So where's a middle number here? Well, the middle number here, it would be 9. So am I using MQ or QM? Which one do you think I should use? So here I went from J to L to the lower side, LK. So I should do the same on this triangle. I should go from QM to MP. See if you can follow that. So this should be QMP. That's an important question here. So how do we know they're even similar? And go back if you need to, if you don't understand that. Again, I could have used, watch, I'll do another one. I could have used, let's say I used JKL. Now I'm going from the largest side. Change the color. We'll use white. Now I'm going from J to K, which is the larger side, to the lower side, the lowest side. So the highest side over here was P to Q. But P to Q is not going to the lowest side. Q to P is going to the lowest side. QPM. JKL. So we'll say QPM. Okay, so how do we know they're similar? Well, we can do ratios here. We can do ratios. So let's say we had JL. Here's that line JL. JL should be proportional to what? Which one on this one? You want to follow the same one. You want to find the middle number. What's the middle number? We have 3 numbers, right? The highest number is 12. The middle number is 9. So from JL, J to L, which is going to JL is part of the lower number too. So what is part of the lower number here? We know MQ, but do we use MQ or QM? J to L to the lower number, Q to M to the lower number, right? So we want to know if the ratio of J to L to Q to M is, we'll find that ratio is 12 to 9, which could be reduced to 4 to 3. We need 2 more ratios, and they all need to come out to 4 to 3 for this to be similar. So let's use another one. I'll use LK over MP. LK is the smallest one going to the larger, and then MP is the smaller one going to the larger. And that ratio is 8 to 6, which, by the way, is also 4 to 3. So far we're good. We have 2. We just need one more side. So I can say JK to PQ. JK is 16, that's the largest side. PQ is the largest, that's 12. And guess what? That goes to 4 to 3. So they all have the same ratio. absolutely same ratio. It's 4 over 3. So these, we now know that they're similar. Okay, let's do a side angle side. Clear that out. And let's say we'll make like a bow tie. Yeah, we have this kind of bow tie here. And let's put in some letters. We'll put T, we'll put Z, we'll put a little W over here. We'll put X, and we'll put Y. And let's put in, now let's say we have a 10 over there and a 22 over there. And let's say over here let's say we have an 11, and over here we have 20. So, if we're going to see if this is side angle side, we want to know that they have two sides congruent and they share an angle. Well, they already share an angle. Right here, they have a vertical angle. Shouldn't use red, right? Use yellow. They share a vertical angle right there. So we know they share one angle already. So let's see if the sides are congruent. And we could do this by something called a scale factor. So if I look at the smaller side of the triangle, 10, and I usually use a K. Most people use K for the scale factor. We want it to equal 20. The smaller to the smaller on the other triangle. If we just do a little algebra, we know we have a scale factor of 2. Let's see if we get a scale factor of 2 for the other one. That'll be 11K. It doesn't really matter what letter you're using, but by convention, they do use K for the scale factor. And we want it to equal 22, and you can see the scale factor is the same. So they are similar. They are similar by side angle side. Let's get another hard one. Let's say I have what we call nested triangles. And that means a triangle within a triangle. Nested triangles. So we'll make a triangle here. Attempting to make one. And we have another one here. So we have two triangles. So let's label them. We'll have this M. We'll put this one P, Q. Right? So we have a big one over here. Just to draw it out. M, P, and Q. And over here we'll just say, we'll call it S and T. Why not? So then we have another one over here. We have S, M, and T. So now we have these two triangles, and they're nested. And here's a term. It's called reflective. The reflective property. And it's very easy to see. They're both sharing an M, angle M. And so we know that angle M is congruent to angle M. It's common sense. So they already both share an angle, so we're probably looking at side angle side, because they already share an angle. Both have M. There's their M. There's the M. So let's write some numbers here. Let's say that was a 5. That's 6. Let's say this is 3. That's 3 3/5. And let's say over here we have an X. And this is X plus 2 1/4. 2.25. So how can we get X? How can we get X? By the way, if you see this line over here, this arrow pointing, then we know that the line here where X is and X plus 2 1/4, we know that they're parallel. Therefore, that their corresponding sides, angle T and angle Q, well, we know they will be congruent. So T and Q are congruent, and also they share an M. So we know that by angle that these two triangles are similar. But let's find X and X plus 2. So let me change the color so I don't make it blurry here. So let's do a ratio. We have one line here, MS, right here. This M and S is 5. What corresponds to 5 on the other triangle? We have 8. So how do I get 8? Well, 5 plus 3 is 8. So we have 8 for that side. And we want to know what x and x plus 2.25 are. So we set up a ratio, just like that. Put a little box around it. And now we just do, we want, if they're similar, they'll have congruent ratios. So all we do is just cross multiply. We're going to do 5 times x plus 2 1/4, and then 8 times x. So let's try to make it a little smaller here. We have 5 times x plus 2 1/4, or 2.25. And we want that to equal 8x. So here we'll have, just distribute 5x plus 11.25 equals 8x. I'm going to subtract the 5x on both sides. Just doing a little algebra now. They'll cross out. Put a little arrow here to continue it. And then we're going to have 11.25 equals 3x. 8x minus 5x is 3x. Dividing out the 3, because we want x by itself, and we know x is going to be 3.75. All right. Let's do one more. Clear it out. And let's say we had a problem like this. This problem has appeared in many textbooks. So let's say we have some person playing tennis, right? We'll say Fred, our friend Fred. So Fred is playing tennis and he's serving, right? So this will be Fred over here, and he's serving, and he's the tennis ball, obviously. He's going to be serving. So when he lifts his hands up, the ball would be here, let's say, and that'll be, we'll say, 7.5 feet. So Fred's not 7.5 feet, but when he lifts his arms to the ball, it's 7.5 feet. And let's say he stands 12 feet away from the net. So we'll say that's 12 feet, and there's the net. And let's say that the net is 3 feet. That's a standard one. So it doesn't look like we have a triangle yet. Let's keep reading the story. So Fred thinks that when he serves this ball at 7.5 feet, it will go 21.4 feet before it hits the ground 8 feet from the net. So 8 feet from the net, that's 8 feet there. And here it's saying that this ball is going to travel. So now we have our triangle, right? We have our two triangles. It's going to go, a total amount from here to here is going to be 21.4 feet. And that's a 3, by the way, by the net. All right, so we have our 8, we have our 12. Let's ask a question on this. How far did the ball go past the net? And by the way, let's label these using white. We'll say, or black. Why not? Just black. We have, let's say that's A. We have A there. We have, let's say that's B, C, D, and E. So now we have two triangles, right? We have ABC and we have ADE. And by the way, there's a right triangle there. There's a right triangle there. They are sharing an angle right here. So we have two angles they're sharing. So by default now we know that through AA that they are similar. But let's try to find, again, X right here. How would we find X? We could break up these triangles. So we have one triangle here, we said that was A, D, and E. That's 7.5. And over here is 20. Because 12 plus 8 is 20. Right? And over here we have 21.4 feet. Then on our smaller triangle over here, we have A, B, C. And we know that this is 3 feet. That's the net. That's 8 feet. and we're just trying to find x. And you could find this by the Pythagorean theorem. Just use the Pythagorean theorem and you can get your answer. And if we did that, we have 3 squared plus 8 squared has to equal x squared, in this case c squared. And so we have 9 plus 64, and that has to equal the square root of 73. So we know x will be around 8.5, we'll just say 8.5 feet, roughly around there. Now, actually, before we go, there's another question that involves when you have x squared. Let's look at that one. Look one over here. Maybe we'll keep black. So let's say we had this triangle, and we cut it in half, and we had we know that's a right angle, and we'll label these A and C and maybe D. Put D in there and put a B over here. And so we're trying to find, and that's x. And let's say that we know that that's 36 feet, and there's y. So, and the total amount from A to C, change the color, is 100. So now we know that y, since we have a total of 100 degrees, we know y has to be 64. So we have two triangles. We have 36. We have 64. Now we know this is 64. And how do we get x? Well, we have 36 over x. We'll make a proportion. And that's going to be equal to x over 64. Just do cross multiplying now. You're going to have x squared equals 2,304. Square root both sides. A little algebra here. So the square root of x squared is x. And the square root of 2,304 is 48. So we found 48. All right, so those are the questions on angle, angle, side, 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 and side, angle, side.